Okay, again, I'm thinking really fast on this one. This one we know is a parabola. It's the parent function of a parabola. Starts here at 0, 0, so I can immediately label that one. It's going to go up on this side, and it's going to go up on that side. Doesn't have to be perfect. I might label 1, 1 on this side, and just to kind of show off, I might label over here that goes through -2, comma 4. A couple of points are good enough. This one right here, top half of a sideways parabola, goes something like that. Even if it's not perfect, this one's going to go through 0, 0, then 1, 1. And then I'm going to make this a really fat point and acknowledge the fact that my sketch isn't very good, but I'm going to tell everybody that this one goes through 4, 4, 2, even if it doesn't look like that. Can somebody tell us what the next nice point is that it would go through? Next nice point. Keely? 9 and 3, perfect. So if that was one you labeled. This is that classic V-shaped, perfect 45 coming in and out. So it's going to go through 0, 0. That's going to be the vertex if you want to say that. And then really you could pick any points you want here as long as like if I go over here to -3, it's going to have the same y coordinate as if I went to +3. So anything along there would be fine. This one probably is the tough one. We haven't done this one in a while. Might help to make a little XY table. Remember, it always goes through -1, 0, and 1. Any number to the 0 power is 1. A negative in the exponent means reciprocal, so this would be 1/4, and a 1 in the exponent means that it's whatever the base is. So this is a 4. So 0, 1, 1, 4, and then -1, 1/4. It's going to look like that. You could really show off on this one by labeling each one of those. So -1 and -1, 1/4. Okay, that looks ugly. 0, 1 and 1, 4. How could you show off on this one? You could say, hey, I remember what the asymptote is on this. That'd be kind of cool. And then y equals x is this one, 0, 0. And any point, they're going to be the same coordinate above and below. So same sign, same number and stuff like that. So this point right here would be -6, -6. What would y equals -x look like? Psi?
It would be straight up and down.
Nope, not y equals x. Y equals -x. Y equals -x.
Oh, sorry, it would be the opposite.
Yeah, it would be going down from left to right. It would go like that, except for it would go through the origin, okay? All right, take your arm and show me what you drew for x equals 5. Just take your arm and show me. That's good. Okay, whenever you have one variable and a number, it tells you what axis it crosses. So we're going to cross the x-axis at 5. So that's got to be a vertical line, okay? So, and as I looked around, it looked like most people got that. That's great. So if I said y equals 0, horizontal line, what's another name for the line y equals 0? Mason? The x-axis. Very good. Okay. All right. Good practice. Keep those. We've got 3 more that we can fill out at some later date. Okay. Would you flip over here? These are the notes for 4.1. This unit is incredibly important. It is amazing how often quadratics come up. Okay. And we're going to do what we call finding zeros of quadratic functions. So quadratic functions. Now remember, quadratics are basically parabolas. We've talked about those already. So we're going to talk about those some more. So here's the deal. We've got lots of practice factoring polynomials already. The average on the test, I think, was 95 or 96 or something like that. So that was pretty darn good. We're now ready to put those skills to use by solving quadratic equations. So we're going to be using 3 different forms of quadratic equations. So again, it's got the highest exponent is a square. Quad means 4. 4-sided figure, square, all that sort of stuff. So each one of these is a quadratic, and each one of them emphasizes different things, and they've got different advantages. So this is what we call this is what we call standard form of a quadratic. And the advantages here are it's nice and compact. We just write it out really quickly like this. It's got lots of information, and it's also easy to put into a calculator. Okay. One of the huge advantages of that right there. So much information just in each one of those coefficients and the constant there. This is what we call vertex form. Okay, vertex is a graph-friendly form. It makes it easy to sketch and do transformations. This right here is the equivalent for me of y equals mx plus b when we're talking about linear. So we did a lot of studying of linear functions and y equals mx plus b. If it's in that format, we can graph it really quickly. If we put a quadratic function in vertex form, we can graph it really quickly. It's a nice graph-friendly form. And then there's something we're going to call factored form, and that's where we may or may not have a number out in front, okay? And then we've got x minus p and x minus q. This is in factored form, and what it does is it makes it easy to find zeros. Now we're going to be talking about zeros a whole bunch. It also makes it easy to sketch kind of important features of it, okay? So vertex form is nice, factored form is nice, standard form is nice. They're all nice, they've just got different advantages, but every single one of these, if we graph them, what shape are they going to make? What's it called? What's the shape of a quadratic called? The quadratic is the name of the function. What shape does it make? Hannah? It makes a parabola. So we're going to be looking at parabolas that go up or go down. Look up here. Maybe they've been stretched, maybe they've been shrunk, or something like that. Are we ever going to deal with a parabola that goes like this? No, not in this class, not yet. What's the problem with this? What's the problem with a parabola that opens to the side? Crew?
It does not pass the vertical line.
You are correct. It does not pass the vertical lines test. So crew, it's not a function. Okay, and we're going to be dealing with functions most of the time. Okay, so to this point, what we've always, when we found zeros, we've used a calculator to find those. So now what we can do is we can use our factoring skills. We're going to factor to find the zeros. There are other ways that we can find zeros, but we're going to start with factoring. So the big question is, let's make sure we all know what is a zero of a function. And this isn't just true about quadratic functions. This is true about any function when we find a zero. A zero is this. It's a value of x that makes f of x equal to, you want to take a guess? 0. It's the number that you plug in, or a number that you can plug in, that makes the function equal to 0. So there are other names for this. You can say the roots of the function. That's the same as saying finding the zeros of the function. You can say, hey, we're finding the x-intercepts of the function, or we're finding solutions to the function. Okay, so all of those are the same. And I just want to make sure we make this connection. Why would we call them zeros? And what do they have to do with this? Mason's got his hand up. Anybody else? Angela's got her hand up. Why do we call them zeros? Gavin's got his hand up. Zach's got his hand up. Angela?
It's because the x-intercept is when x equals y equals 0.
When y equals 0. When the function value equals 0. That's basically what we're asking. So all of these are talking about the same thing. So if somebody says 0, root, x-intercept, or solution, they're talking about the same thing. Okay, and it depends on who your teacher is, what the textbook is, and different things like that, how they're going to talk about that. So one important thing that we're going to take advantage of, we need to make sure that we understand this is easy. Elementary school kids, kindergarten kids love this. This is the product property of 0. And it basically says if a product is equal to 0, at least one of the factors must also equal 0. So if I've got a multiplication problem sitting right here, so if I've got a times b equals 0, I know this for absolute fact. And we're going to use this fact to our advantage. If a times b equals 0, then we know for a fact either a is equal to 0, b is equal to 0, or it might be that they're both equal to 0. Okay? So we're going to come down here and we're going to find some zeros of these functions. Now, before we find the zeros, this is what I'd like you to do for just a second. This entire chapter, this entire unit is about quadratics. What shape is a quadratic again? Parabola. It's a parabola. So stop and think about this for just a second. Roughly, what would this look like? got an x here, and it's got an x here, and it's got a 2 in front there. This would look like 2x squared. Does it open up or down? Opens up. Stretched or shrunk? Stretched. About 2 times steeper than it normally is. That is enough information right there. The other stuff that goes along with that, not too worried about for right now. We're going to find other details about it, but just looking at this mentally and saying, oh, that's a parabola that opens up and it's been stretched is really helpful. You'll see those on the back side. So if we take a look at this right here, what we want to know is what are the zeros? In other words, when does this equal 0? So here's the deal. I've got a multiplication problem. Remember what factoring is? Factoring just says, hey, would you write this as a multiplication problem? Hey, they already did it for us. Huge advantage. So here's the deal. This times this equals 0. So using this idea up above, well, either 2x has to equal 0 or x plus 7 has to equal 0. And then I just solve that. So on this one, I'm going to divide by 2. I get x equals 0. That is one of the answers. That's one of the zeros. It happens to be 0 in this case. Sounds weird, but it is. Solve this one by subtracting 7 from both sides, and I get x equals negative 7. I get 2 zeros for this. There are the answers. That's all we're looking for. It says find the zeros of each function. We just found both of them. Now, why does this actually work? Watch. I'm going to change colors on this, and I'm going to say, look, what we're saying is when you plug in a 0, you get a 0 out. So 2 times 0 times 0 plus 7. This is 2 times 0 times 7. It's all a multiplication problem. It's a product, and there's a 0 in there. Is the answer 0? Yes, it is. So I'm going to do the same thing on this one. I'm going to plug in a negative 7. This is 2 times negative 7. Negative 7 plus 7. Negative 7 plus 7 is 0. So it doesn't matter that the 2 times the negative 7 makes a 14. It's going to get multiplied by 0 anyway. So the answer to the whole thing is 0. So the function value, the y value is 0, which means it hasn't gone above or below the x-axis. It's right on the x-axis. It's a solution. It's a root. It's a 0. It's an x-intercept. Okay, any questions? Okay. Can you look at this and tell what answer comes from here? Technically, you'd do this. You'd say, when does this part equal 0 and when does this part equal 0? Dane, what's the answer that comes from here?
A positive 5.
Very good, a positive 5. Can you tell me the other one real quick?
-9.
A negative 9, okay? And it really worked on each one of those because all we're basically doing is taking the opposite of that number. Kind of cool. So if I come back up here, you have to be a little bit careful with this. If I come back up here, the 0 for this one would be the opposite of this. It would be P. The 0 for this one would be the opposite of that. It would be Q. Okay? Now, don't get too carried away with that because it gets slightly more complicated. It gets complicated if we don't have it factored. If it's not factored, we have to factor. So I'm going to ask Luke. Luke, what's the first rule in factoring?
Take out the greatest common factor.
Take out the greatest common factor. Would you look at example 2A and would you tell us if there's a GCF?
I think 3 might go into 2, so I think it's 3.
Okay, does anybody know the quick way to tell if 3 goes into something? What's the quick way to tell? Angela?
So if you add 7 and 2.
Add the digits.
9.
Okay, if you add 7 plus 2, you get 9. Is the sum divisible by 3? Yes, that means 3 will go in here. Works for gigantic numbers. I'm just going to write one down at random. Watch. Okay, it's the number 2,567,192. 7 plus 6, that's 13. That's a 20, that's a 21. That's 32. Is it divisible by 3?
No.
No. What if this was a 3?
Yes.
Yep.
Yeah.
Yep, it would. Okay. All right. So we can take out a 3. Let's take out a 3 and look what we're left with. We're left with an x squared. We're left with a minus 11x. And we're left with a plus 24. That riddle question comes up over and over and over again. I'm looking for numbers that multiply to be 24. that combine to be negative 11. Can somebody raise their hand and tell us what they are? Jack, what is it?
-8, -3.
He's right. Take an extra second right here, double check and make sure, because if you don't double check, it literally takes less than 5 seconds. Do they multiply to be positive 24? Yes. Do they combine to be negative 11? Yes. Don't forget the 3 out front, and I'm going to write down something silly. Is there any way that coefficient out front is going to make it 0? No, we get no solutions out there. Can somebody tell me why there's no way? And we've got an example up above. I'm going to slide this down here. Why does this one not give us an answer? Take a look at this and take a look at the one above. Why does this one not give us an answer? Why is there no solution from this one and we get an answer up above? There's a big difference here. Gavin?
There's no variable.
Yeah, there's no variable. If there's not a variable, there's no way that's going to be the part that makes it a 0. That's a constant. This one right here, we get a 3. The other one, we get an 8. So we get an x equals 3 and we get an x equals 8. Now, if I just write 3 and 8, is that okay? Probably ought to write something like x equals 3 and 8. Probably write the zeros are 3 and 8 or something like that. You probably just wouldn't want to write down 3 and 8. Okay. Abby, any common factors on this one? Any common factors? Nope. What are we stuck doing? Yep. Multiply the first and last. Coefficient on the squared term, constant on the end, negative 60. And then I'm looking for some numbers that multiply to be negative 60 that combine to be negative 4. Some people like writing down those two numbers off to the side, writing a times and a plus next to them, stuff like that. I just like just highlighting them either mentally or physically. I need two numbers that multiply to be negative 60. So one of them's got to be negative. Combined to be negative, that means the big one's got to be negative. Sai, what do you think?
-10 and 6.
Negative 10 and 6. I'm going to write negative 10 and 6 off to the side here. I'm going to take the extra 5 seconds. 10 if I'm yapping like this. Multiply to be negative 60? Yep. Combined to be negative 4? Yes. So we're going to be okay on this. This is going to be 4x squared minus 10x plus 6x minus 15. I'm going to take out I can take out a 2. This is going to get interesting. 2x minus 5. And I can take out a 3. I'm taking out a positive 3. Let's make sure it goes in there twice. The x is left with a minus 5. So I have a 2x minus 5, and I have a 2x plus 3. Factored, right? Piece of cake after this. So 2x minus 5 has got to equal 0, or 2x plus 3 has got to equal 0. Colson, what do I do to solve?
Add 5.
Add 5. Then what?
Divide by 2.
Divide by 2. So I'm going to write everything out here. I'm going to have a 2x divide by 2. So I get x equals 5 halves. Make that look good. I'm going to circle that one. Andy, what do I do to solve this one?
You subtract 3.
Yep. So I'm going to get a 2x equals negative 3. And then what?
You divide it.
Divide by 2. So I get x equals negative 3 halves. Okay. Everybody good with that? Okay. Can I see a fist? This is horrible. I have no freaking clue what I'm doing. Or a 5. This is pretty good. 4 is like, I'm pretty close. Fist to 5. Okay, not too bad. Okay, here's what I want you to look at. Does anybody notice anything about these numbers in this factor, the coefficient and the constant, and the answer right here, and the coefficient and the constant, and the answers right here? Kind of like here and here, here and here. Does anybody notice anything? Okay, Keely, what do you notice?
The coefficient is in the denominator.
The coefficient is in the denominator.
And then the other one
and it flips signs. So if I were to write something like this, if we came up with a general one, so this is a numeric example. I want to show you something. If what she's saying is true, what if I had a factor that looked like this? AX plus B. What would be the zero that comes from that? If what she said is true, what would be the zero that comes from it? Jack?
Negative A over B.
Close.
Or no, B over A.
Negative B over A. That's what it would be. Does that work every time? It does. It does work every time. In fact, watch. I'm going to put a 1 on that. Opposite of this is 8 divided by 1. Do I get the right answer there? Okay, now 1 isn't a good thing to test things on, but it does work. Okay, so Keely's idea will work just fine right there. So flip over to the back side. Here's what we need to do. And again, this is where you want to think of what the graph looks like. By the way, what does that graph look like? Parabola opens up. I have no idea where it's been moved, but I do know that 4 stretches it vertically. So it's 4 times steeper than it used to be. So let's come over here and take a look at this. So I think we've got 2 more problems on the backside. These are graphing ones. We're going to do the following, and I really don't care what order you do these in as long as you get everything done. Just do it in an order that makes sense to you. So the first thing is find the zeros of each function. Find the vertex, and it's got a hint there. Use the zeros in symmetry to find the x-coordinate of the vertex, and then we can kind of go from there. Complete the XY table with at least 5 points. Include the zeros in the vertex, and then graph the function. Okay? So let's do this. What's the 0 that comes from this one? Oh, come on. 2 hands? Seriously? Lizzie, what do you got?
6.
This would be 6. X equals 6 would be a 0. What's the 0 that comes from that second factor? Thanks, Luke. That was fast.
1.
X equals 1. Now, if I want to, again, to emphasize why we call these zeros roots, x-intercepts, or something like that, I'm going to come over here and I'm going to put a 1 and I'm going to put a 6. And each one of the y coordinates there would be 0. Now, where I put those doesn't really matter. I happen to put them at the end. Would you take a look at this guy right here? Can anybody tell us roughly what this looks like? And Mason, you shouldn't have your calculator out. Mason.
Mason.
Should I swap it out for one?
If you want to. You don't need your calculator for this. Keely, what does it look like? What is it? She's got it. It's an upside down parabola. This is roughly what we're looking for, okay? So if you want to, we can kind of do these pieces all at the same time. I'm going to put a 6 right here, and I'm going to put a 1 right here. And Keely just said this looks like an upside down parabola. Huh. Wait a second. If this is an upside down parabola and it goes like this, can somebody tell me about where the vertex would be? Because isn't there an axis of symmetry on these? Wouldn't this go right down the middle? Because it's going to go something like this. I mean, that might be a crappy drawing, but it's going to look something like that. You think so? I did actually hit both points, and that was fast. What's the x-coordinate of the vertex? Zach thinks he knows. Be really cool if you could tell it where it is and how you figured it out. Zach?
3.5.
Zach thinks it's at 3.5. Why do you think it's at 3.5?
Because it's symmetric through the center of it.
It's symmetric through the center of it, okay? So it would be right in between the two of those. So what's right in between 1 and 6? Add them together. Listen carefully. Add those x coordinates together and divide by 2. So they add up to 7, so that would be 3.5. So it's going to be somewhere around right here, okay? So if you want to write 3.5, that's fine. If you wanted to write, let's see, what would that be? 7/2? That would be okay. Okay, watch. Probably haven't seen this before. I'm going to plug these numbers in here. I'm going to figure out what the what the y coordinate is. So I'm going to plug in 7/2. I'm going to plug in 3.5. That's going to give me negative 2.5. That's going to give me positive 2.5, which would be negative 5/2 and positive 5/2. Negative times negative is positive. This would be 25/4, and I don't need a calculator. Now, if you want to use your calculator and type it in, I don't want you to use the graphing stuff. If you want to type into your calculator 3.5 minus 6 and then 3.5 minus 1, or you want to do that mentally and have 2.5 times 2.5, throw that into your calculator. That's totally okay. This is one reason why I like fractions. I know the answer is 25/2, and I didn't have to reach for a calculator, which means this is 6 1/4. Okay, so 25/4. So that means it's about right here. Good? Okay. Now, I'll be honest with you. Have we graphed the function? Done. Have we found the vertex? Yep. Did we find the zeros? Yep. I'm not too terribly interested in if you get 5 points on this, but it might not be a bad idea to pick at least maybe one more. I'm going to pick the number 5, and then I'm going to pick one more number. Can anybody think of a number that would be ridiculously easy to plug in? Luke, what do you think?
0.
0 is always a nice one to plug in. Okay? And watch what happens when you plug these in. When you plug these in, I'm going to have a negative 5 minus 6, 5 minus 1. So this is going to be a negative. That's a negative 1. That's a 4. So I end up with a positive 4. Does that look about right? Does 5 comma 4 look good? And if you plug in a 0, we have a negative, 0 minus 6, 0 minus 1. Here's what's going to happen every single time. This is just going to turn into that number that's in there, that constant that's in there. So this is going to be a negative times a negative 6 times a negative 1. 3 negatives make a negative, and then we're over here. It happens to cross at 0 comma negative 6. Couple real key important points here. You ready? This is a darn good graph. Here's why it's a darn good graph. You have basically all the important features. We know where the vertex is. We happen to label it over here. We know where the x-intercepts are, and we know where the y-intercept is. That's why it's nice to choose 0 to plug in there. Okay? Any questions? Okay. What's wrong with this one? Wrong in air quotes. Okay? Maybe wrong's not the right word. What's not so nice about this one? Dane?
It's not factored.
It's not in factored form. Can somebody tell me something that is nice about this one? Other than Dane? Okay, we'll call on Dane again. Go ahead, Dane.
You can graph the parabola easy.
Yeah, what shape is it?
Parabola.
Parabola opens up. Okay, factor it. Take out an x. X minus 2. This one's a piece of cake. We've covered this already. It crosses at 2. That is a 0. So I'm going to put a 2 about right here. What's the 0 that comes from this factor? Okay, here's the weird thing. Please don't let this screw you up. Look up here, please. This happens all the time. People stare at this and go, I don't know, there's not a number with it. Okay, the reason that one was a 2 is because we set it equal to 0 and we just solved it. Set this equal to 0 and solve it. Lo and behold, it is its own answer. X equals 0. So those are the two zeros right here. So if you put in a 0, you get out a 0. If you put in a 2, you get out a 0. 0, 0, 2, 0. Stop and think for just a second. Where's the vertex? X coordinate is easiest to find first. Where's the vertex?
On the x coordinate 1.
X coordinate of 1. Add those two together. You get 2 divided by 2. You end up with 1. So we're going to plug in a 1. If you plug in a 1, you get 1 squared minus 2 times 1. Or you could plug it into the factored version. Either way, you're going to get negative 1. Now, can you look at that? Can anybody give us another point really quickly? Quick draw. Isn't this the standard pattern? Vertex, right 1 up, 1 squared. Right 2 up. 2 squared is 4. So that would be 3 comma 3. So we'll do a 3 comma 3. Going the other way. Back 2, up 2 squared. That would put us right here. So negative 1 comma 3. Here's what it looks like. All the important stuff on there, and we are all set to go. Any questions? Okay, Luke, what was our goal today?
To learn stuff about the parabolas.
To learn stuff about parabolas. A little more specifically, what did we want to know about parabolas, and what name did we give them besides the
Figure
parabola?
zeros and quadratics.
Zeros of quadratics. Would you rate how you feel about yourself right now? In math. In math. Let's be specific with that, shall we?
Hungry.
Okay. I am feeling super, super generous today. Get this. We're going to get rid of multiples of 10.
Thank you so much.
Thank
You are so welcome. So welcome. Okay?
It means the world to me that you did that.
It means the word. Oh, that makes me want to cry. Okay. Number 1, list 3 other terms that mean the same thing as 0. Lydia, give me 1. X-intercept. Perfect. Megan, give me another one. Solution is another way to say it. Caleb. Root. Root, x-intercept solution would be fine. In your own words, explain why the product property of 0 is true. You don't have to get too in depth on this. Yeah.
Anything times 0 is 0.
Perfect. I'll take something like that. If you multiply by 0, you get 0. Anything times 0 is 0. Anything you want to say like that is fine.
Aren't we solving it when we're doing zeros? Aren't we doing y equals 0 or f of x equals 0?
Solving? Yeah. So when it says find the zeros, that's the same as saying solve this. So if we take a look at number 1, we're basically saying when does y equal 0? When does f of x equal 0? When are we on the x-axis? So we're replacing that with a 0 and then solving it. And if it's already factored, gosh, I'm hoping you're done with number 3. And if I talk for 5 more seconds, you're done with number 4. And another 5 seconds, you're done with number 5. These go pretty quickly if they're factored. If they're not factored, it takes a little bit longer. Okay, any questions? All right, great, go.